In college algebra, we started chapter 2, Basics of Functions. So we start out talking about domain and range and whether or not something is a function. So first off, in order for you to find the domain, you need to look at all the x's, and to find the range, look at all the y's. So for example, on number 1, if each of these coordinates is an xy, then your domain is very simple. Just list out all the first numbers. So the domain is 5, 10, 15, 20, and 25. The range is all of the y's, so it's the second number listed. 12.8, 16.2, 18.9, 20.7, and 21.8. And that's it. If they ask for the domain and range and you have coordinates, it's a little different if you're looking at a function like a graph, but if they give you a bunch of coordinates, that's all you do. On number 2, you're trying to decide if it's a function, because there are cases where it's a no. So if an x is repeated, used more than once, it is not a function. So you look at all your coordinates, and if any x is repeated, you say no. So on example 2a, I see a y is repeated. That's not an x, so that's okay. All the x's are unique. Yes, it is a function. No, let's not use the word no. Each x is unique, is used only once. That's a way to say it. On example B, look at these 6's here. These two 6's make the answer a no, not a function. Let's write it differently. X's are repeated. And then to narrow that down to 6's are used. There we go. All right, now let's look at some actual equations and determine if it's a function. So down here in number 3, they give you an equation. And I'll be honest, I think it's a little difficult to check it algebraically, because it sounds very backwards from what I just got done saying. But let me write it down. Algebraically, if only one y is produced when an x is plugged in, then it is a function. Now I'm going to show you an easier way to do this than algebraically, but anyone interested in not picking up a calculator and just looking at this thing, this is how you do it. So first off, solve for y. Then plug in a value for x. If you get two answers, it's a no. If you get one answer, it's a yes. If two answers, two Ys. If one answer, one Y, then it's a yes. So let's try it. On example 3a, we need to solve for y, so let's move that x squared over. And we get y equals negative x squared plus 4. So there's step one. Step two, plug in anything you want for x. So I'm going to plug in a 1. Plug in a nice number. And I get a 3. I get one answer. Yes, it is a function. Now I'll show you another way in just a second. On part B, I'm going to run out of room. I want to go through the same steps, but I need to get rid of that exponent of 2 above the y. So I need to square root both sides. And I get a plus or minus. And if you're clever with your algebra, you see the answer is going to be no right away. Because if I plug in a 1, I'm going to get plus or minus the square root of 3. Two answers, that's a no, not a function. Now I'll be honest, I think the algebra way is a little confusing. So if I just confused you, grab a calculator and let's type it in. So two ways to type in each of these. You go to a graph, and you could type in, treat this f1x as a y, and then you would type in negative x squared plus 4. And you get this upside down parabola. There's this thing called a vertical line test, and if you draw a line through any point on this graph, and it only crosses once, then you say yes. So I'll draw this on the actual slide over there. What happens if you don't know how to solve for y? Because you'll get some complicated ones sometimes. Let's clear that. Press Doc B. Go back to a new graph and hit Menu, Graph Entry. If you click on Relation, you can type it exactly how I typed it. X squared plus y equals 4, and you get the correct graph. And you see it crosses only one time. It is a function. What about the next one? So graph entry, relation, x squared plus y squared equals 4. And we get a circle. When I draw a line through that circle, it crosses it twice. That is not a function. All right. So maybe in your notes, let's clear that. Back to your notes here. If instead of the algebra, now you've run out of room possibly if you wrote everything that I did, but somewhere find some empty space, that graph looks like this. And when I draw a vertical line through that, it crosses only once. So we want to say yes, it only crosses once. On part B, it makes a circle. and this one crosses twice. So that's a no. It crosses twice. All right, so somewhere on your paper, maybe write down what the vertical line test is. I'm going to write it right up here above those problems. So it's called the vertical line test. I'll write it over here. I don't think we've written anything over here yet. Draw a vertical line. Through the graph. If it crosses once, then yes, it is a function. If it crosses more than once, that's a no. All right. So I think you've heard of this vertical line test before. If you don't like the algebra way, I would do it the vertical line way. All right, moving on. Last thing we did in class was number 4. It says evaluate. When it says evaluate, we need to plug in the number or expression in question and simplify as much as possible. Sometimes we'll be able to get down to one number for our answer, but other times we're going to have x's in our answer. So you're going to add like terms, do as much math as you can, and once all like terms are combined, you stop. So on part A, we plug in a 2. And we get 4 plus 6 plus 5. Our answer is 15. So that one's pretty simple. Most people do well on that. But on questions like B and C, people tend to struggle and do too much work. We're going to plug x plus 3 in anywhere we see an x. Otherwise, we're just copying what I typed above. When I see that x plus 3 squared, I write it twice. And then you got to FOIL it out. So that means you draw the arcs and do that thing. All right. Over here on the middle term, you're going to distribute. So we're going to get 3x plus 9, and then we still have that 5 there. All right, almost done with that one. We get x squared plus 3x plus 3x plus 9, and then we still have all this stuff. Now only add like terms and you're done. We only have one x squared term. 3x plus 3x plus 3x is 9x. And then 9 plus 9 plus 5 is 23. And you stop right there. Part C, I would make sure you use parentheses because that negative disappears for one term, but it doesn't disappear for another term. So when I plug in that negative x, I get negative x times negative x, and that's a positive x squared. But over here we get negative 3x. And that's all for that part. Remember, only add like terms. That was it. I will see y'all later. Bye.